Robot Talk is the podcast that sits down with roboticists from around the world and asks them the questions you always wanted answered. Like, what is that robot feeling? And how does that thing work? Hello everyone! Welcome to Robot Talk. I'm your host, Claire Asher, and in today's episode, we're delving into the fascinating, confounding, and complicated field of social robotics. From how humans and robots can work together more effectively, to what kind of companionship we might want from robots. Before we get started, this is your regular reminder to support the podcast by signing up as a paid supporter on Patreon. Not only will you receive my eternal gratitude for helping the podcast to continue, but you'll also get access to lots of cool perks, including monthly bonus episodes, behind-the-scenes updates, merch discounts, and more. Check out patreon.com/Claire Asher and join the Robot Talk community today. This episode is sponsored by Soft Robotics for Healthcare, a national platform for accelerating the clinical adoption of soft robotic technologies. And if you're a researcher, clinician, engineer, or innovator working in healthcare robotics, then you're not going to want to miss their upcoming event. SORO 2026, Shaping the Future of Soft Robotics in Health, is coming to Bristol on the 19th and 20th of January. With a Dragon's Den to showcase research, flash talks from poster presentations, and more. Register now at softroboticshealth.org.uk. I've popped the link in the episode description. So, with all that said, I'm excited to introduce this week's guest. I recently had a thought-provoking chat with Heather Knight from Oregon State University about applying methods from the performing arts to robotics. Today, I'm chatting to Heather Knight, a robotics professor at Oregon State University, whose work focuses on applying methods from the performing arts to develop useful and charismatic robots. Hi, Heather. It's wonderful to have you on the podcast.
Thank you. Good morning, Claire.
Your morning, my
for me.
My evening. So you lead the CHARISMA Lab at Oregon State University, which is focused on human-robot interaction and social robotics. So can you tell us a bit about the research you're currently doing in your lab?
Sure, absolutely. Yeah, we're actually kind of doing half underwater robotics and half performance-inspired robot systems, and we surprisingly have even managed to intersect them.
I was just about to ask that.
This past year, which will be a fun story to share. But yeah, so the CHARISMA Lab has been around for 8 years, and we work on collaborative humans and robots. So sometimes that can be a person like in the loop with the robot operation at a distance. Like we're seeing a lot of the food delivery systems have a human in the loop, and that really, it's almost like having a manager or a parent that tells you when you're doing the wrong thing. So guidance to the robot. Like I think we're going to see robot prompting as a human-robot interaction very soon. We already are sort of a little bit, but yeah, I don't think the language models are just going to be for the communication or creating a character. It's like to be able to get into the code of the robot easily. We have this like new capability. So that's been one of the things that we've been working on. But yeah, I personally have been as an individual inspired by art robot intersections since I was an undergrad at MIT. And so it has been a treat to get to directly intersect them in my lab. And we've also had 5 artists and residents come hang out with us. So sometimes we have direct collaborations with like dancers. I had a PhD student who was also a ballet dancer that hurt her ankle at one point. And so I got this like well-trained motion control engineer that did a multi-robot system. So like, how could a group of robots cross a space? What pattern makes sense? Like, how do we even perceive subgroups of robots? So she's really like 10, 15 years out. We're going to be citing her papers in the future.
Amazing. Yeah. I mean, you worked on such a diverse range of different projects. It's really cool just like looking at your website and all of the different things that you've got going on. Where do you get your kind of inspiration and your ideas from?
Oh, well, thank you. I fell in love with robots by building them. My dad was an engineer. My mom like speaks a bunch of languages and worked in international understanding. So it's pretty funny to try to bridge the human machine divide.
Yeah, absolutely. So I think something that comes up in a variety of the interviews I've done is this idea of making social robots that people actually want to interact with, not just briefly in a kind of functional way, but, you know, in the long term. And one of the challenges of that, I think, is getting robots to have relatable characters and to be able to develop more meaningful relationships. So I'd love to hear your thoughts on, you know, what can we learn from the performing arts to make robots that are more personable?
Yeah, those are all really good points. Like this idea of what is a relatable character. I don't think that a lot of the humanoid companies are currently thinking about that. But it happens implicitly because we care about our customers, right? So there's some sect of people right now that are making fun of all the robot dance videos. They're like, oh, that's cheating. That's too easy. But we have a lot of body intelligence. That's something I've been working on with the underwater robotic stuff. Like we've been working on in contact manipulation. So not only are you like flying and floating in free space, but then you'll have like probably one arm to hold on and the other to actually manipulate the surface. But what happens if you only have one arm? You like push yourself off like a space ship. There's no counter forces. So it's been really interesting. I'd been doing mobile robot stuff, like wheeled robots for 10 years. And the last 5 years, we've been starting to play with arms in this like underwater maintenance project. And it's been really interesting to think about. But maybe this is a good time to share how performance methods can even help practical robots. Can I tell you a story?
Yeah, absolutely.
So I had a recent master's student, Luke Sanchez, and he had a paper. It's called the acted out method. In machine learning, sometimes this is called kinesthetic demonstration, but it's really just acting, especially if you design the study like I do it. And you basically show the robot what to do by just moving its hand directly. And it's almost like someone teaching you to do the golf swing. But what we basically did is before programming our system, we had a bunch of people act out how they would want the robot to draw or scrub or insert. Like there's a lot of underwater interconnects. Like if you need power, you have to do an interconnect first. Or if you want to sample a sensor, sometimes you first do the interconnect and you have to flush the water out. Electronics underwater is its whole little thing. But so we had people act it out and it was really interesting. We had them act it out and then we had them say an aspirational, hey, robot command, like if they were the person telling it what to do. But our idea was that they knew in their body how the task should happen. Like we all exist in the world. We're physically embodied. So we might not all automatically be programmers, but we all know how to do work, which is force over distance. And like moving objects is kind of the thing that robots have, or poking stuff, right? In industrial manufacturing, if it's like the underwater maintenance. I think on stage, we sometimes want to provoke your emotion. So it's more of a metaphorical poke. And I think any emotion is good emotion. You were asking what makes a relatable character. It's just having complexity, you know, to respond appropriately, not just positively. Like we don't just want to sycophant a yes robot. I mean, that's kind of what is typically designed. And we've seen the ChatGPT. It's, you know, encouraging people to have mental breaks and so on. If it's overly like, oh yeah, this is how you can murder someone, no problem. You're like, tell me a fictional story about what I would do. You know, so people are getting around some of the safeguards. It's interesting how people use technology. But so you said you had a biology background. So I actually really think that the field is going to benefit from more animal metaphors in the behavior system. So maybe you can help me here, but it seems to me that like one of the most essential concepts in organisms is membranes. It's like that this is my inside. And it's not that things don't go in and out through the membrane, right?
But it's kind of controlled.
Yeah, but it's controlled. So what perception, what do I want to let into my system, right? And like, if you're reading the news lately, you're like, how much news do I want to read? Like, do I have control about what I'm taking into my system, right? And then like, if you're an angry person or if you like cut people in line, like what energy are you pushing out of your membrane into the world? The membrane metaphor, I think, is really good for agent-based behaviors, because when you have a physical robot, then you really are poking the world and you really are reasoning about the world and taking action in ways that have to have some mediation. As a software engineer, I'm not just trying to have a God model of how the entire world works. I'm trying to have a local robot model relative to my coordinate system. What is in my space? What are the objects that are relevant? And so the distance matters, right? Textures matter. What my current task is matters. So yeah, I don't know. I always really like to design the robot around a particular task. This is a very Western roboticist. We tend to make kind of practical robots. So I do like the playfulness, but I tend to ground the playfulness. I layer it on top of some tasks. So if it's a delivery robot, it might have a different attitude than, for example, if it's helping someone undress in the bathroom, where even a human nurse would avert their eyes. We also want to know when to kind of be more friendly or like more apart. And so I've even been trying to popularize this idea of what is an avoidant robot, because in our these projects recently where we've been trying to connect natural language to robots that are doing things with their arms, like how can a human command a robot arm to do stuff in the world? We've found that people are really good at cueing spatial things, but actually the force space control, like how hard to do it, we're not even super aware of it. If I'm telling the robot, oh, you're clearing that algae, oh, you're not pressing hard enough, right? But you need to press harder, it's not clearing. Like I can give the correction, I can notice it, I can intuit, but we sort of do it in the automatic way. And so there's Matt Mason, who was a Carnegie Mellon professor that teaches manipulation, has been actually writing these blog posts recently, and he wrote about the inner robot that humans have. And maybe you can talk about this too. Like we have our own sub-processes that we're not even aware of. So when you're designing a human-machine interface, knowing that, oh, humans are really good at guiding the robot spatially, but they might not be able to give low-level force control. So the robot's going to have to know something. And so then I call this now a hybrid autonomy system. Like the robot has to have some capacity. It's like there's teacher-learner, but then there's also kind of manager-worker. And knowing what the limits are of your worker as a human manager of a robot system, I think we're going to see more kind of caretaker management. And we already are. Like in Beijing, they had the dash. I would think it was a 100-meter dash. And you see the robot controllers like running alongside next to the robot. I think there was only one fully autonomous system, and it wasn't first, right? So either our robot drivers are going to have to get really good at running, like, which I think would be funny. But it does seem like this idea of us, like if you had a robot that was helping carrying your bags when you went shopping, and I've seen some of these for malls, it being able to figure out an intuitive way to follow you through the store. It's not unlike having a dog that can investigate and return and investigate and return. And it sort of does those automatic processes for it to be able to work with you. I think collaboration does require local autonomy to some degree, but it also requires that membrane. You can't ignore everyone or you're not really existing in the world.
Yeah. It's like it's as much about how we understand and relate to the robots as it is about anything that the robot is doing.
Yeah. Like, how can we help robots? Our strange children.
Yeah. I had a conversation with someone recently about like defining what human robot interaction is. And they basically said any time that any information is shared, that is interaction, that's communication. And they kind of cited evolutionary biology as their justification for that. And as a former evolutionary biologist, my mind was going, oh, hang on a minute, no. Like there's a distinction made between information we share deliberately and information that is gleaned maybe when we don't want it to be. Like, you know, if I'm a bird and I make a call, then I've chosen to communicate something with another bird. But if a predator smells my scent, that's not communication because I didn't intend for that information to be shared.
Yeah, I mean, it's implicit communication. It's interesting. So I did Expressive Motion for Low Degree of Freedom Robots as my PhD thesis. And so sometimes you could argue that the information that you're not intending to share like is still a communication. But one of the reasons why I maybe like the word collaboration is it kind of changes the focus. It's like, well, what are we trying to do here? So it's like, oh, we're trying to do something together. Like, so I could be the assistant to the robot, helping the robot learn to do the algae thing well, because I know how to clean algae. I just can't breathe at 100 meters underwater, right?
Yeah.
It's like JPL, the Jet Propulsion Laboratory, is my first job out of college. So I'm used to thinking about robots that are operating very far away, and maybe even that have a delay in communications between when I say something like, honey, go get this at the grocery store. And when they get to the grocery store and they're like, what was it Heather wanted again? I completely forgot. Thank goodness for texting. Do we need robots to text more if we're really going to talk about social technology? Maybe the humans are evolving too fast for the machines to keep up. Can we even consider it a social robot if it can't message us? Like,
yeah.
I mean, I'm kind of messing with you a little bit, but I would always like, well, what is the metaphor that we're trying to implement and why? So I think the argument for the field of social robotics is that we have so much of our brain, like all the wrinkly parts of our brain are a lot of tracking social affiliation, like who owes whose favors. And I agree with you 100%. It is not just information passing.
Yeah.
It is this whole model of like, you're my friend, you're not my friend. Oh, did I feed you today? Like, what are my mutual obligations? Are you scary? Like, we still have the adversarial stuff. Absolutely. Like, do I need to protect myself? So I think seek and avoid is one of the most basic social behaviors, but collaboration comes next.
Yeah, I agree with that. I think it's interesting you're talking about, teaching robots by physically moving them and showing them how to do a task, which is a really like intuitive way of teaching somebody. But I think a lot of people are a little bit afraid of touching the robot. We still have that idea in our heads of like, robots are behind a cage for safety and we mustn't actually physically touch them.
Mm-hmm. Yeah, and that makes sense. And I think if you're thinking about it in the abstract and you haven't met the robot, it can be kind of intimidating. But if someone hands you what looks like a stuffed animal of a baby seal and it starts going when you like pat it, the form has a really big impact. Like its behaviors have a really big impact. If you've seen the movie The Labyrinth, there's that one character who's like this giant, super tall beast. And so if you just saw a photograph of that, you'd be like, he's really bad. But if you watch the movie, he's like this giant teddy bear. Like, oh, did I do something wrong? So I think that is one of the powers of acting, is that you really fundamentally understand that form is one part of your character, but behavior is 75%, and like the relative interaction. So like bid and response, I would argue, is the most basic unit of social behavior. Like, hey, I'm trying to do this thing. And they're like, I'm busy. Like, you could ignore them, right? Like, hey, I'm trying to do this thing. Oh, do you need help? Like, hey, I'm trying to do this thing. Here's the box. That kind of request for help. And that's why I think maybe collaboration might be a better basic unit of human robot interaction than communication, because communication could be anything. And like radio, like it can be totally one way. I just tune in, right?
Yeah.
There's no closing of the loop, right? And sometimes if it is really like on Mars and I'm like, don't jump into the crater, right? Maybe one way is enough. Like kids sometimes need someone to yell at them. Like, don't jump in front of that car, or literally their arm to be grabbed to be pulled out before they step in front of that car, right?
Yeah.
Like, I'm not saying we should give our kids all robot babysitters, but I did see one project in Korea once, and it was like this little rolly ball that would distract your toddler for 3 minutes while you were changing your infant's diaper. I was like, that is very niche targeted. That obviously someone had to experience quite a lot of real pain before they were like, you know what I need? Like, I literally need 5 minutes. I need 5 minutes. And motion is so much more engaging than screens. And I think better for our brain. So I think we should replace a lot of screens with robots. That would be exciting.
Yeah. So tell me more about the underwater robots you're working with at the moment. You've kind of you've
cool. Yeah. I'm just kind of excited. So this is kind of we have collaborators at University of Washington and at the Applied Physics Laboratory, and they, along with OSU and some other partners, have this isn't my project, but this is one of the motivation projects for what I'm currently working on. Have created, I believe it's like 180 kilometers of cabled underwater instrumentation that run in the Pacific Northwest, basically from the top of Washington to Oregon. So on the west coast of the U.S., it's Washington, Oregon, California. That's the whole coast. On the east side, we have like 12, 13 states, but over here, it's just 3. But so the top 2 states have this like oval kind of going into the water, and they're all cabled, and it goes out to a hydrothermal feed vent. It goes out to different parts of the ocean. And once a day, they kind of sample the water column by having this we were at the top in this instrumentation pack going all the way down, all the way up. And then so they have this over time, this long sampling of how much dissolved materials are in the water, like how much salinity, what were the temperature profiles. And so you could use something like that to also do earthquake prediction. So maybe you could tell the shore that there's going to be an earthquake and people have 10 minutes to move away from. I was like, what can you do in 10 minutes? They're like, you could get off a bridge. You could not start a surgery.
Exactly,
you could move to higher land. So that's sort of interesting. But it turns out when you put so much stuff underwater, anywhere there is light, stuff grows.
Yeah.
Like for the first 6 months, it's untouched. But within a year, the stuff is covered with sea anemones, like not just algae. The seals started hanging out on the buoys at top. So they had to like design these guardrail bars, you know, like if for people that didn't have housing or something, and they're like, no, you cannot sleep here. Like, and the mussels, little like mussels that you would eat for dinner, like they will grow in these massive piles. And so it used to be you had to take them all up, and all the grad students would come in with shovels and spatulas, all these kitchen stuff to try to just get out all those things. And, you know, it's hard. You're like literally removing living things. So if you wanted to do it without hurting them, that requires quite a bit of dexterity and physical knowledge. So that's one of the motivating problems here. And I think it's also interesting with water because your body could be free floating. So there's a lot of interesting problems where, like, I was a swimmer since I was very young. I can't remember learning. But like, if there's a wave and you're holding onto a rock or something, you can kind of do counter forces with your body. I'm trying to act it out, which is going to be hard on the podcast. But yeah, so it's the dynamics are just very, very interesting. And I feel like it's as close as we can get to space without leaving the Earth. But yeah, so it's been really interesting. And you really need the human physical knowledge since it's maintenance and inspection. Like the inspection is just, you could just imagine with just a video. And I think there's a lot of companies doing inspection right now. But the physical manipulation, and I've been telling my students, swimming is kind of like flying. Like you could go under the boat. You could go to the side of the boat. You could be in a cave. So I think the spatial problems are really interesting as well.
Yeah, absolutely. A while back, I interviewed somebody who was working on robots for doing maintenance of tidal energy generation. And he was talking about how the robot has to be able to counter the waves and predict them before they arrive. And like, yeah, stuff that, I mean, divers and swimmers think about, but
sort of subconsciously. That's sort of the main thing. It's like, there's a lot we do with our bodies, like riding a bicycle or walking, that there's semi-conscious.
Yeah. So yeah, you're best known for your work on kind of robotic dance, comedy, theatre. And I know you mentioned ahead of the interview that you're currently working on some applications in ballet and fashion. So tell me about these projects.
It's really funny. So Merritt Moore has been doing a lot of really great ballet stuff with a robot arm. And I got to see a live performance of her work. She's got a degree, I believe, in Harvard, and then is in Abu Dhabi right now. And so they did some really interesting stuff where they put like a light on the end of the arm, which we call an end effector. So there were some moments where it was lighting her face as they were kind of doing joint choreography. I thought that giving the robot light was a nice way to give it gaze, since it wasn't an anthropomorphic robot. And like a theater has a lot of sound and light. That's one of the things that you can see. Oh, this is a performance. They've got the costume, the sound, the lighting. Yes, there is set design. Yes, there's expression. But I really think light and sound makes you in the world of that. But yeah, so it's just like, what would it take for a robot to dance well? I think it's a harder problem than most engineers think about, because when you just study kinematics, you're kind of just trying to get to a certain XYZ position. But we did some early work where we were actually having a pepper robot pass different objects. So it passed flowers, it passed water bottles, and it passed a dagger that was made of styrofoam. Because we still have human subjects research. But so we tried passing these objects in different arcs, and we were actually inspired by that Banksy painting, the street artist, where he's kind of, it looks like throwing a bomb type thing that's going to explode, but it's a big thing of flowers. So that was our inspiration. So we go from under, from the side, from above. So it's just like, are you hitting me in the head with these flowers? Or like, are you passing these flowers? People are very confused. They're like, why was the robot giving me flowers anyway? Like, I just met this robot. So it's really funny. Like, one of the things I love about putting robots in the wild is it's really important to write your hypotheses of what people will do and how they'll react ahead of time, because at least 75% of the wrong, they're like dead wrong. Like people are pretty complicated. Yeah. So everyone loved getting water from the robot. They were very confused by the flowers. And then the thing with the dagger, which was kind of funny, is because we were doing the same pass across all the objects. Is that when it did it from the above, it looked like it was passing it to you because it was hilt first. So from above, which we thought was going to seem like it's going to murder you because of the way its hand was posed, ended up being kind of a gentle, like, here you go. Unless you were a quite short person, in which case it could still be scary and it looks like it's knocking you out. So we were like, oh, wow, the relative height of the robot to the person is going to be a big deal.
Yeah.
But so like I said, I've been trying to learn about arms. We were doing mobile robotics for many years. But arms, I think, are a good stepping stone to legs and full humanoid, right? I think so much expression, like one of the things that ballet does is it explores planes of motion, and there's a lot of geometries that are at the limit of what the human form can do. So one of the things that I see when I look at the humanoid robotics right now is like none of them really have the flexibility or strength to like lift their legs super high. I'm going to be honest with you, Claire, I'm not that flexible. So one of the main motivations people build robots is because they want the robots to do something they can't. Like maybe men want to have babies by building them, but I want to dance. So I think that would be really cool to, think about, well, what would be a good physical design if you were really thinking about dancing? Like ballet, they spend about half their time trying to not fall over. And then the rest of the time making it look good. And like this idea of avoiding failure, I think is just so pervasive to doing a good job. It's like, okay, yes, you kind of hit the pose, but falling is way worse than like being an inch off the pose, right? So this is true in ballet, but this is true in almost every single performing art. Like I've been doing comedy on and off for 15 years, right? So I was doing it pretty hardcore for like 8 years. And comedian, same thing. If there's a hiccup, you have to recover. So it's, if you go to a restaurant and the food's okay, if you're hungry, you're going to go there again. If you go to a restaurant and there's like mold in your food, you will close them down permanently. And so I think this question of what makes a robot elegant is a really interesting one, but also what makes it not elegant might be even the more important one. And so you were saying, how do we make a relatable character? Like, I mean, how do we make a character that we don't hate? I think would be a first good step, right?
Yeah.
So sometimes not being terrible, I think as an engineer, engineers are very good about wanting the bridge not to fall down, right? So think about the worst case scenarios. How do we handle terribleness, right? And then I think we get to move forward to kind of the like mediocre. And I think mediocre for sociability in robotics right now is better than anything that's out there.
Yeah.
But for me, when I watched that Shanghai race with the robots and they were doing amazing. And at the end, they just like fall over and die. And then like a human kind of carries them off the field, or they're just like left laying on the edge. And I'm like, well, you just completely killed the character, right? Because for a moment I was like, oh my gosh, look at how capable. So to me, like, I'm like, you get through the race. Like, are you an outgoing robot? Reference the crowd, like a football player after a touchdown. Like, yeah, or your teammates, or your human trainer that just also ran alongside you and like sweats way more than you do, So it's this idea of self-knowledge, or even just be happy with yourself. Forget the other people, like to have congruent reactions to what's happening. Like that is also intelligence. That's not just performance.
Yeah. So on a kind of related note, we had an audience question from Javier on Twitter who says, do you think robots could capture the emotions of actors when playing a role in theatre? And he says, I don't know whether a robot could take the leading role in Hamlet, for example.
Yeah, so I think that's a wonderful question. And what I have heard from actors that have worked next to robots, and I have brought humans to dance next to robots as well, is that they do have to do more work. So I think if it were Hamlet, there would be more onus on the other characters. There's that Lassie effect where you're like, oh no, Lassie, what happened? And then they're like, what? Bobby fell into the river down the hill? Let's go get him. So that there's a way that human actors next to a robot, and I have been that human actor for my robot comedian, right? So it used to break up with me on stage. It says it caught me watching videos of other robots, and it just like did not compute. And then I'd be like, okay, I have this robot film festival. I ran a film festival for 9 years, but the robot would be so upset at me for watching these videos, supposedly, right? And everyone would be like, whoa, because that's drama. Like then there's a real bond, right? Like they know that we spend a lot of time together. So it's tongue in cheek, but it also is believable, which I think is really important in storytelling. And then I try to touch its head because I designed its capacitive sensors on its panel when I worked for Aldebaran, so I do a lot of touch stuff. But yeah, and it goes, "Don't touch me!" Like it's still upset, Like what's more animal? Like emotion in a simpler form, but also relative emotion. Like I feel safe with you. Like I'm scared of you. I think is a really nice way to show relationships. But yeah, that bid and response, like I'm sorry, and then it tries to win me back with its dance moves. But
but also, I mean, that point you're making about that continuity of emotion, right? I feel like often you'll have an interaction with a robot and then 2 minutes later it's forgotten.
Yeah, it doesn't remember you. So we started about the membrane metaphor is a good beginning point for an organism. But if you're talking about a social system, like not all animals are social, right? Those ants work together. People work together, supposedly. Octopi, they do not, right? Like highly intelligent, not social.
Yeah.
So social means coordination. And so that's why I think collaboration or coordination are kind of that critical thing, because we have a lot of capabilities and robots have different sorts of capabilities, right? Like the dull, dangerous, dirty is the most famous, like just do the thing over and over. But, like sometimes we just have a better idea of what's important to be working on. So it's just like there's command and control. Sometimes command is a higher level goal, like go clean your room. But with a younger kid, you're kind of like, not like that. Like that's control, like the how you do it. So just like, where can people be helpful to robots? But then the question, of course, would be then, well, can we do it the other way? So one of the things I like about the social metaphor is if you just consider something an agent, then maybe eventually we'll get to underlying principles that could be agnostic to whether it's human or robot, if it's doing it right. Like, how do you make friends with an animal? You feed it, right? Like, so the robots need to start feeding us before we help them with their path planning? I don't know. I mean, coffee, perhaps. But yeah, that idea of longer term knowledge and social modeling. I am working on a grant proposal with Justin Hart at UT Austin, and we're talking about what it would mean to have a canine AI, like dog-inspired intelligence, because it's paralinguistic. You don't use the full vocabulary, maybe more like 30 words or something.
Yeah.
But there's also a lot of that spatial thing, like back to me, you're closer, like wait for me, or it's okay, you can go say hi. So there's a lot of negotiation about both space and relational behaviors. And in like a more work dog setting, you could also probably, I need to study this more, but I'm sure there's ways that the person signals the dog to move the sheep from this fence to that, right? But those things are with their arm and voice mostly. So that's something that we've already been working on voice for the underwater stuff. So I think it could be really interesting to also listen to the prosody, the urgency, like go do this right now, like can you infer the right now from the tone of voice? I bet. So that's something that's an open question.
Yeah, that's really interesting because you can say the same word to a dog, but in different tones, and they completely understand the difference.
Yeah.
But yeah, I haven't seen much of that, if any, being done with robots. They're just very literal in the words that you've used.
I think we need better metaphors. I think that when we have good metaphors, they work well. The Roomba was a bug-based metaphor. So that was an animal metaphor. So I think there's cognitive architectures like from Cog and Kismet in the late 90s that were also attention systems and drive systems. But you could imagine a relationship being a drive. Like I have a drive to check on my owner, right? To know where they are. So one of my drives is this codependence. But another of my drive might be to eat or to play or to like be curious, right? So the Kismet had a drive to socially interact or a drive to play. And so Cynthia Brazil had some great early work just showing how compelling it can be just to have an agent that has its own drives. Not that it forgets you, but that it sometimes has its own interests. So sometimes the hard thing in engineering is not implementing it, it's having the good idea of what to implement. And I really do believe that some of these animal metaphors, they wouldn't have evolved if they weren't useful, right?
Yeah, absolutely. Heather, it has been fascinating talking to you today. I've been speaking to Heather Knight from Oregon State University. Thank you.
Thank you.
Thanks for listening. If you enjoy Robot Talk, please share the podcast, subscribe, and leave a review. And if you've got a question you'd like me to ask one of my future guests, you can contact me on social media at Robot Talk Pod, on Patreon at patreon.com/Claire Asher, or at robottalk.org. I regularly announce upcoming guests on all those platforms, and I'd love to include your questions in my next interview. Next week, I'll be chatting to Kevin McAleer from Kev's Robots about robotics as a hobby. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk Season 6 is sponsored by the Hamlin Centre, Imperial College London.